Good morning, everyone. I'm just going to give it a couple minutes before we actually officially get started, just for in case anyone is wrapping up any meetings before they can join this, and then we'll get started in about 1 or 2 more minutes. Thanks. All right, we're going to get started now. Good morning, everyone. This is the Getting Started with Kubernetes training. My name is Denise Shannon. I'm a program manager here at Rancher. With me, I have Rajashree. Rajashree, you want to say hi?
Hey, everyone.
So today's objectives, we're going to go through a technical introduction of Kubernetes using Rancher. We have a couple of slides to go through, but mostly the training will be about demoing and demoing some more. In the GoToWebinar on the side, there is a little question bar that you can ask questions as we go through our demo. If you have anything you want us to clarify or anything specific you want to get answered, you can ask it there. We'll be, depending on who's presenting, we'll be alternating answering the questions. We'll try our best to be answering as many questions as we can before the training is over. Just before we actually get started, there are some resources we want to show you about. So one is the documentation. So at docs.rancher.com, there is a specific Kubernetes section that you can find. Here's the link. But if you just go to docs.rancher.com, you will be directed to the main site. And then in the nav bar, you can go to the Kubernetes section to see all the different sections that we have specifically focused on Kubernetes. We also have forums. So forums.rancher.com, if you go there, you can, excuse me, join in. Our community is really active. If you have any questions of like how you're getting set up or questions of how you might want to do things, you can get it set up there. We also have a Slack channel. I'll share that at the, I think it's at the end of our slides of how to sign up there. So a couple key topics that we're going to go through today. One is setting up Rancher. Just a quick note about that is that this is not a intro to Rancher training. We usually have those every month as well. We haven't quite set the schedule for 2018, but there will be one in January of just how to get up, setting up Rancher, all the options that are there today. I will briefly go over a very high level of the bare minimum requirements that you'll need to be able to set up for this training today. But otherwise, if you want to learn more about Rancher or it's your first time using it, I highly recommend attending that other training. That can be found on our website. If you scroll to the bottom, usually when we have it scheduled, you can register there. I'm going to walk through deploying Kubernetes, how easy and quick it is to do it through Rancher itself, and then I'll give you a little details how you can set up kube control. At that point, I'm going to hand it off to Rajashree, and she's going to go through some of the Kubernetes concepts that are out there: pods, deployment services, config map, ingresses, give you a description of what those concepts mean, what does that mean in Rancher, how you can use it in Rancher itself. So sometimes some people ask, like, well, why would we use Rancher and Kubernetes together? From us, we find it that it's, better together, mostly because it's really easy to deploy and launch Kubernetes. If you've ever tried to set up Kubernetes yourself, sometimes it's a little more difficult, especially if it's your first time. It's really easy to just launch Rancher, and then you can launch a Kubernetes environment. That's a Rancher concept, where basically you would launch the containers that you need to be able to run Kubernetes. We offer like a one-click upgrade, so when you go from between Kubernetes versions, usually as they roll out, we try and package those in our Rancher releases as they come out as well, where you could upgrade from one Kubernetes version to the next with one click of a button. You could set up, excuse me, sorry, I'm struggling with a little cold today, so you can easily set up your services in Kubernetes, be able to see it, use the Rancher UI, which is nice and easy to look at, to be able to support your Kubernetes cluster, at least the orchestration part on how Kubernetes is running. And then we as a company we do offer 24/7 support. Let me get out of my slides here. So for today's training, all I've done is I've set up 4 boxes in AWS. They are actually running Rancher OS. That is a small Linux distribution that we as a company have started. I only pick it because once you launch it, Docker is already installed. It's really quick to start up. You can use whatever Linux operating system you want to be able to start. You do not have to use Rancher OS. So I've already logged in on one of my boxes, on my server box. I've already started the latest Rancher server, which is version 1.6.13, which is what we've just released yesterday. I started that up about an hour ago. So that's up and running. And then over here, you can see I have basically pre-pulled all the images that you will need to be able to get Rancher or Kubernetes and Rancher running together. So these will be my hosts in Rancher, and I'll go through what we need to do to add them. So on the host that is running the Rancher server, let me just hide a couple things. Everyone can see it a little bit better. So here's my box that I have it. When you launch the Rancher server container, you're going to expose port 8080. That's where the UI is. So on the doc site, just so that you're aware, if you've never used Rancher, you can go under installing Rancher. They'll give you all these options of how you can install it, what the requirements are. And then basically, all I did this morning was I ran this command of, let's run Rancher server. I made it so it restarts unless stopped. So if your host reboots, it will restart Rancher server unless you explicitly stop the container. I've exposed port 8080 for the container. Now you can see in the UI, all I've done is I had originally just gone to this URL. It logged me in. Usually what comes up is there is a page that comes up, asks if you are willing to allow us to collect some anonymous stats. The stats are just mostly for us to understand, what environments are people using? Are people using mostly Kubernetes? Are they using our internal cattle orchestration? We have a couple of other container orchestrations that we support as well. It also collects some stats in terms of what OSs are you using. That's really just helpful to allow us to make better decision in terms of which OSs we should concentrate on when we are doing our testing. We try and test as many combinations as we can. Obviously, we're not going to be able to support everyone's unique combinations, but we try and do the mainstream ones as much as possible. So once you enter here, the main thing you want to do is, the first thing you'll see is this red highlighted button. It'll say access control not configured. What you want to do is go to admin, go to access control. We support a lot of different authentication providers. For this training, I'm just going to turn on local, which is basically Rancher is storing the username and passwords locally in the database that we have as part of the container. Now that I've turned on access control, basically it automatically logs me in, but anyone else who wants to try and go to my IP during this training would not be able to go in and start playing around with it. The next thing I'll need to do is add an account for Rajashree because she is also going to need to be able to log in. I'm going to give her admin access. Okay, so now both of our accounts have been created. So now we're going to go into manage environments. So as I kind of discussed at a very high level before, we're going to add what we call a Kubernetes environment. So an environment is based off of the environment template. By default, Rancher starts up with of the container orchestrations that we support, the different default templates that are available. Here you can see there's a Kubernetes one. I'm actually going to click on edit this because there are actually a lot of Kubernetes configurations that you could do depending on how you're going to launch, what your setup is, what your networking is. So in the default Kubernetes template, here you'll see that the orchestrations that's selected is Kubernetes. I'm going to click on edit config. Here you'll be able to see what version of Kubernetes is supported with this version of Rancher. And then here you're going to be able to see that under the configuration options of Kubernetes, there's a lot of different options. So I'm going to go at a high level about what these options are. I'm going to try and click through to the doc site as well to show you where you can read more about it so you can make good decisions on it. So here under plain isolation, there's none in required. Basically, when you select none, which is what the default is, all your Kubernetes components, whatever you're going to end up deploying as pods in Kubernetes, where etcd lands is all going to be on the same host. Usually in a production environment, we strongly recommend that you choose actually doing a required plain isolation. In order to do the required plain isolation, there is a lot of options, or not a lot of options, a lot of requirements in terms of what you need to do in terms of setting up your hosts. So here in the docs under Kubernetes, there's resiliency planes. And here we talk about the data plane. That's where your etcd containers are going to be. We have our orchestration plane. That's where all the containers that Rancher is going to start up and launch to be able to support Kubernetes itself. And then your compute plane is where the hosts are going to be where your Kubernetes pods end up getting deployed. So usually you want to isolate those so that, if there's some problem with one of them, it won't necessarily affect your workload. And here it will talk about what the planes are and what are the requirements and how you need to set those up. For today's demo, I'm not going to do that because it usually requires a couple more boxes than I've set up. Next there's this option of cloud provider. So we currently support the Rancher cloud provider, and then AWS and Azure. So basically, the different options are really when you start to use what kind of host you're going to use and which ingresses, when you create an ingress, what you want your load balancer to do. So for the Rancher one, you can basically create your hosts anywhere you want. It could be any cloud provider. It could be locally. It could be on-premise. There's lots of options there. When you launch an ingress, which is basically creating like a load balancer for you, they would use the Rancher's internal HA proxy load balancer. If you choose AWS or Azure, you're basically kind of dedicating yourself to say you're going to do everything in those cloud providers. So for AWS, you have to have EC2 hosts. When you use an ingress, it will create an ELB. For Azure, same thing, Azure hosts. And here under the next option in our Kubernetes navbar is the cloud providers, kind of what that means, kind of what I described kind of quickly. Also how you need to set it up. For AWS, there's going to be some specific permissions that you're going to have to set up. For Azure, how you're going to have to configure that as well. There's some Azure options there. So then the next one will be Kubernetes RBAC. So I think as of Kubernetes 1.6, they supported RBAC. By default, it's turned off. If you want to enable it, you can enable it to work in conjunction with the authentication piece, that layer that Rancher puts on top of it. I would not recommend enabling this unless you really know what you're doing. It's very specific. There's some details about it here, about what you need to do, but basically if you enable it, when you log in, basically you would need to apply all the roles to the different users and groups that are going to be able to use your Kubernetes cluster. So really, before you jump in and automatically enable it, thinking that you want to turn RBAC on, please make sure you read it before you get there. If you are using a private registry or you have an air-gapped install, there are a couple of steps that you'll need to do to be able to launch Kubernetes. Not only Kubernetes itself, but the infrastructure stacks that Rancher runs to be able to manage Kubernetes itself. Here you put where your private registry is. Let's see. And then there's a couple of different ones of where you can change, well, I guess, let's see how I would describe it. Basically, where your add-ons. So when you launch Kubernetes, there are these add-ons that we start up automatically. There is Helm, there's Dashboard, so the Kubernetes Dashboard, there's SkyDNS. Those options have where you want those containers to be launched from. You can change that. You can enable all of them, or you could disable them. Most people enable them. I'll show you why, because of we automatically launch these add-ons and then you have access to them. So there are some of these options here for that. And then I'm going to glance through. There's a lot of options. There's for the add-ons itself. And then as we get further down, it's definitely much more, specific if you know what you're doing about Kubernetes. It's already defaulted to what we recommend in terms of if you're just getting started to just play around with it. And then the backups and etcd, this is all about etcd. So I'm not going to change anything for today's demo, but, as I said, most of these options do exist or talk a little bit more about in our Kubernetes section. You are welcome to configure it here. You will need to configure it under the template itself before you can create it. Cancel. But by default, it's made so that you can run right out of the box without having to configure additional properties that you might not know about. So here I'm going to add an environment, and here you can pick your Kubernetes template. So, you could, in theory, make a template. I'm just going to go back real quick. That would be Kubernetes with RBAC on. I'd select Kubernetes. I'd edit the configuration, and I could turn RBAC on. Configure, scroll down, and create that template. So now when I want to add an environment into Rancher, I have the option of, I could pick the Kubernetes that has RBAC on, or I could pick what the default one is. So I'm going to pick the default one today. I'm going to also add registry into my setup. So when she logs in, she should be able to access it as well. Immediately what you'll do is you'll see when you go to this environment, I switch to this Kubernetes environment, you'll be seeing that you need to add at least one host. So here under infrastructure host, I'm going to add hosts. So when you add hosts, there's a bunch of different options you can have. You can either launch directly in a cloud provider. What we do is we just call Docker machine. There are other machine drivers that you can enable. We cover all these options, or at least how to do them, in the regular how to use Rancher training. For this purpose, I'm just going to basically add, since I already started these 3 other boxes with these images, I'm going to copy and paste the command to run the Rancher agent container. I'm going to go to my 3 boxes and run this command, basically. And because I've already pre-pulled all my images, it's just going to start running up. When I close this, what should happen is these hosts should pop up fairly quickly, and then it'll automatically start to launch these, what we call infrastructure stacks. So to be able to create this managed overlay network where it allows the containers to talk across to each other in the hosts, we launch these infrastructure stacks that are required. One is IPsec and network services. This is what those two set up your networking. There's a health check, so that will help you maintain the healthiness of your containers itself. The Kubernetes stack, this is what I'm going to enlarge or expand. This one shows all the different services that we use to be able to get Kubernetes up and running. So really what we're going to do is we're going to wait for this to all be active. So now it actually became active really quickly in my environment, but that is because I had pre-pulled all the images. So if you don't have any of these images pre-pulled, it's going to take a little bit for it to download these images before it'll get up all and running and active. After Kubernetes is up and running, usually I like to go to the CLI here. You can generate a kube config. You can put it where you're locally are. That's what Rajashree is going to do. So she can run kube control commands from her laptop. And here we also have a handy shell to be able to look at what's going on in Kubernetes. Usually what I like to do before we move, or before I hand it over to Rajashree, sorry, I'm just typing, is to make sure all of these add-ons, these are some pods that we already have started on the machine, are up and running. It says they are. I'm going to go now. Since the dashboard is one of those add-ons, I usually like to check before I move forward. Go to the dashboard and then click on here. And it'll proxy you over to basically where the Kubernetes dashboard is. And here, this is the Kubernetes dashboard. You'll be able to, click around, be able to see what already exists. There's different namespaces. So if I go to the kube system one, you'll see this is where all of our add-ons are actually already running. Okay. So now that Kubernetes is up and running, I'm going to move over and hand the presentation to Rajashree so she can start going.
Okay, so you can see my screen?
Yes.
Okay. Okay, so this is the cluster that Denise just set up, and I just logged into it because she had provided me the access to it. And yeah, as she said, I'm going to generate the config over here so that I can use it from my laptop shell as well. And I'll just have to paste it in my kube config. Okay, so I should be able to start using this, start using my shell to access the cluster.
Oh, I'm gonna interrupt you 1 second. So someone says that it seems like we've lost audio.
Oh,
I'm not sure how that's necessarily possible because we're actually have been using we're in the same room. I just changed the presenter so she could do it. So I don't know if anyone out there can hear us.
Can you hear us?
Oh, there's someone else who says that they can hear audio. Thank you, Ananda. So Srinivas, sounds like maybe that your audio has the issue. So hopefully you can. I will message him specifically because obviously if he can't hear me, he can't hear you.
Yeah.
So I'm gonna hand it back, or I'm gonna stop talking to let Rajashree continue.
Sure. Okay. So yeah. So let's go over some of the few core Kubernetes resources. And the resources that I'm going to cover, they are purely Kubernetes concepts, and it's nothing Rancher specific, or they are not custom resources. So they'll be the same no matter how you spin up your Kubernetes cluster. So the first one we look at is a pod. Now, a pod is the smallest unit that can be deployed in the Kubernetes cluster, and it consists of one or more containers that are tightly coupled. Kubernetes supports multiple container runtimes, but Docker is the most commonly known one. And each pod gets a unique IP address, which makes it accessible by all other pods and services within the cluster. So, like I said, the containers in the pod are tightly coupled. What that means is they get scheduled on the same host. Then they can also share the same storage volumes. They have the same network namespace. Which means the containers in the pod can share the IP address and port space of the pod that they are running within. And this is why the containers can also find each other via localhost. Now, this concept of pods is useful Because say if you want to run a helper process along with your main process, now you can just combine these two processes within the same container. But instead of cramming too much in the same like the Docker image, you can instead start two separate containers within a pod, like one for the main process and one for the helper process. One example can be, say, if you have an application that constantly needs to access an external DB. So for that, you can start a pod with two containers. One will run the main process that needs to access the DB, and the second one can be like a helper process. So what this helper container can do is reroute requests from the main container to the external DB. So our main container can can keep doing all the DB operations via localhost without having to do any service resolution or anything, and the helper process can keep accessing the external DB for the main container. But apart from these very specific examples where we need multiple containers in a pod, usually most of the use cases have only one container per pod. So you might also see on Kubernetes documentations that one container per pod model is the most common Kubernetes use case. And so that's what I'm going to use for the remainder of this training session as well. So let's go ahead and take a look at how we can create some of these pods. So for creating the pod or any of the resources in this training session, I'm going to use something called as a manifest. Now, manifests are files in YAML format, and this is what they look like. So these manifests contain a few fields that are common to all Kubernetes resources. Some of the fields are common. So basically, you will have to provide the API version for any resource you create, and the kind, like we are creating a pod right now. Metadata is where you can provide things such as what you want your resource to be named. You can also provide what namespace you want your resource to be created in. And under spec, you can provide the exact description of your resource, like what you want your resource to look like. So I want to create one container within this pod that is named shell. And I want the container also to be named shell. And I'm using this image. This image does nothing much. It just basically lets you exec into it and run some curl commands. And yeah, so that's it. Let's go ahead and create this pod. Now for creating it, I'm going to use the kubectl create command. And to that, I just need to provide this manifest as an argument. So it says that it has created the pod. And as you can see, it is currently getting created. It's taking some time maybe to pull the image. Yeah, and now it's running. So now let's check out another example of creating a pod. Now this is another manifest, and as you can see, most of the fields are same because I'm again creating a pod, and I wanted to I want to name it as Nginx, and I again want a single container within it with the name Nginx running the Docker Hub Nginx image, and I'm exposing port 80. So let me create that as well. Okay, so as you can see, like Kubernetes keeps telling us the actual state of the pod, like whether it is in container creating or if it is restarting for some reason or if it encounters some error. But in our case, like both the images got pulled correctly and the cluster is set up right, so we have both the pods in the running state. So I said that each pod gets assigned a unique IP address, and you can find out the address, and one way of doing that is by using the kubectl describe command. So I'm just going to use it to get the IP address of the pod Nginx. Now what describe command does is it gives you a detailed description of the resource that you want to find out. So it provides you with information such as the IP address that got assigned to the pod or the node it got scheduled on, then its current state and what all events took place, and so on. So I also said that you can access one pod from some other pod using the IP address, and let's see how we can do that. So for that, I'm going to use the IP address of the Nginx pod. I'm going to try and do a curl on this IP address from within the shell pod that I created before this. So for that, let me exec into the shell pod. So for this, I'm just going to use the kubectl exec command, which is very much similar to the docker exec command, if you're familiar with that. And now I'm into the pod. So let me just do a curl on the Nginx pod's IP address, and it works. I can access the Nginx pod because this is the Nginx homepage. And so this is how you can use the IP addresses of the pod. So now, okay, before that, yeah, I just wanted to show you another manifest. Like we saw two manifests which didn't contain much information, just how we can create one container in a pod. But there are many other fields that you can specify or like provide through a manifest. For example, if you want to add some environment variables, then you can provide them in this manner. Or if you want to do some volume mounts, you can specify the mount path and then add the volumes under like using this volumes key. So now I'm going to move on to the next concept, that is deployments. So the pod that we just saw, pods are basically ephemeral. When you start a pod, it will get scheduled on a host. But if the host goes down or if the pod itself goes down for some reason, then Kubernetes won't know that it has to reschedule it again. And we can't take that risk. That's why we won't run our applications directly on a pod in the cluster. Instead, we will use the Kubernetes deployment resource to manage the life cycle of these pods that we want our application to run on. So what deployment does is it uses the concept of desired state versus actual state. Meaning when you are starting an application using the deployment resource, you will provide it with the desired state of your app, which includes the image that you want to use for your app, then the number of pods that you want running, any environment variables that you want to add, and so on. And then deployment makes sure that the actual state of your app is the same as the desired state at any point. So let's go ahead and create some deployments. Also, in some previous Kubernetes tutorials, you can see replication controllers being used, but replication controllers are now deprecated, and instead we use deployments. Again, to create the deployment, I'm going to use a manifest, and like I said, a lot of fields stay the same. For example, API version. Now, the kind of resource that we are creating is deployment, and I'm naming it Nginx. Now, if you see under spec, there's this field replicas. So this replicas basically lets us specify the number of replicated pods that we want to run for our application. And in our case, I just want to run 3 pods. Now notice the field labels, and like I'm providing a label app Nginx. What this means is any pod that gets managed by this deployment will be assigned this label app Nginx to it, and we'll see how it can be used in just a few minutes. Now again, under under template spec, you can provide what you want the containers to look like within these pods. So I'm just starting one container named Nginx, and I'm using the Nginx 1.13 image, and I'm like using port 80. So now to create this deployment, I'm going to use another command called kubectl apply. Now what this does is, like we saw that kubectl create lets us create a new resource. Apply also creates a new resource, But if there is any if this resource already exists and if I am making any new changes to it, then I can use the apply command to just directly apply the changes instead of having to recreate the resource. So it says that the deployment has been created. So yeah, this kubectl get command that I'm using, it basically lists all the resources of that kind. I mean, I just did a kubectl get deployment, so it will list all the deployments that are there. And these are the 3 pods that were started by this deployment. Okay, so now like we have 3 pods running for this deployment, meaning the scale of the deployment is 3. But for some reason, if you want to change the scale of the deployment, you can do it via the kubectl scale command. This is one way to do it. So you do kubectl scale, then name of the deployment, then yeah, you provide replicas as say 2. So it has been scaled, meaning we should see that one of the pods will get terminated and there will be just 2 pods remaining for this deployment. And okay, so that has taken place. So it has been scaled down to 2. Now, let's say I want to go back and scale it up to 3 again. Now, for that, I can use the kubectl edit command. What that does is it just opens up the resource in an editor and it provides you the detailed description of that resource. You can see most of the fields over here are what we had provided while via the manifest file. And over here, you can go to scale replicas and change the number to say 3 again.
That's fine. I have a quick question for you after from someone wanted to know how can we have multiple containers in a pod?
Okay.
And then also, I think it might help if you could show the actual containers that are being launched.
Oh, right.
So if you go infrastructure.
Yeah, I forgot about that.
And then uncheck.
Yeah, just system.
Right. Is your Nginx.
Right. So at the very first, when I was discussing pods, I created this Nginx pod. So this is the container for it. And like same for the shell pod. And these are the, you can see some big names attached to it. Now these are the pods that are being managed by the Nginx deployment that we just created. Now, sorry.
So the question was, how can we have multiple containers in a pod?
So the YAML file that we saw, within that you can specify like different containers. For example, let me just finish this example and I'll go back to the manifest for that question. So we were looking at the kubectl edit command to scale up our deployment back to 3. And I made the change in spec.replicas. And once I quit the editor, the resource will have been edited. So you can see that one more container got added. Right. So one more pod got added for the deployment. And if I do a get on the deployment again, you can see that the desired and current is 3 again. And so going back to the question that was just asked. Okay, I'm just going to use this manifest as an example. Now over here, I have provided that the name of the container is shell. So just below that, you can add more such specifications for any other containers. You can provide what names you want to use for them and what other image you want to do, you want to provide. That's how you can provide what all different multiple containers you want to run within the pod. And like I said, all those containers can talk to each other via localhost. I hope that answers the question.
Okay. Yeah. Hanashu, let me know if you have more questions. Oh, so someone else had a further question. So within that manifest, you can add the Nginx in there.
Yeah, you can add any container, depending on your app, of course, what all can be run together. So you can add different container specs and different images. Okay, cool. What was I? Right, okay. So coming back to deployments. Now, we saw that how we can create a deployment using the manifest, but you can also start it using the kubectl run command. So say I'm creating another deployment with the name nginx2, and I'm just going to use the Docker Hub nginx image, and say let's create a deployment with the scale 2. It says that a deployment has been created. You can see on the left on the host, a few containers have been added. And if I do kubectl get deployment, I have the second deployment running as well. Okay, so this covers the things that I wanted to discuss about deployment. So let's go to the concept of services. Now, we have seen how the pods get assigned a unique IP address, which makes it accessible to other pods and deployments in the cluster. But again, pods are ephemeral. So if the pod goes down, like even if it is being managed by a deployment, the deployment will bring up another pod in its place. But this new pod will have a different IP address. So any of the other pods or deployments that were accessing this new, like the previous pod, need a better way of keeping a track of the. All pods need a better way of keeping track of what pods they want to access, and that's where we use the concept of services. So service basically provides a DNS entry that can be used to refer to a group of pods, and it gives consistent endpoints for the group of pods, and it's similar to load balancers in functionality. So let's go ahead and check out how that works.
So someone asked a question, why is the version in pod manifest different than the one in the deployments manifest?
Oh, right. So that depends on the way Kubernetes is like developing these resources. So these versions can keep changing depending on the Kubernetes release. So I think pod was created at the very first, and it had version v1, and deployment until Kubernetes 1.8, it was under version extensions v1 beta 1. But now they have changed it to apps v1 beta 1, and soon, like maybe in the next release, in GA, they are going to move it to some other version. So it entirely depends on how Kubernetes is handling these resources with different releases, and all of that information is available on the Kubernetes API docs.
Yeah, so one of the things that we've at least encountered in terms of Kubernetes, one of the things that always, comes up that I don't think is maybe that you need to follow along Kubernetes distinctly is that the API versions that they use for their concepts are constantly between at least their minor upgrades from like 1.7 to 1.8, 1.8 to 1.9. Between those Kubernetes versions, what happens is they often graduate, they'll introduce a lot of concepts in alpha, and then they'll move it to beta, and then they'll move it to actually a V1. Where that's actually located could also change. So when you're moving and upgrading from one Kubernetes version to another, you'll need to make sure that you check the API docs to see that your manifests are still matching, aligned with the API versions that Kubernetes has.
Okay, so I'll go back to creating a service. And again, for that, I'm going to use the service manifest. And yeah, even that's under, like, its API version is v1 right now. And again, it can change later on. So I want to name the service as nginx. And now if you see under spec selector, there's this selector app nginx. If you recall, we had assigned this label app nginx to the nginx deployment that we had created. So what this will do is, it will route any traffic coming to the service to any pod that has this label assigned to it. Meaning all the pods that are being managed by our nginx deployment, traffic coming to the service can be routed to those pods. And these are some traffic routing rules. We are routing from port 8080 to port 80, and also from port 80 to port 80. So I'm going to create this service. This SVC, these are just some aliases that are available. And okay, so the service has been created for nginx. Now, like I said, using the spec selector, like the label app nginx, traffic can be routed to any pods that have that label on it. So let's see how that works. Just a second. Okay, so for that, like I need to make some curl requests. So I'm going to again exec back into the shell pod that I had created. Okay, let's see how I can access this service, basically the DNS entry that was created. Now the way to do it is, like this is a Kubernetes convention. You first provide the service name, then the service namespace, then SPC cluster local. This is just how it's done in Kubernetes. And right, okay. So this is our Nginx homepage. This is because we did a call request to the Nginx service, and that request got routed to the pods that had that label app Nginx on it. And those pods are basically running Nginx containers. And that's why we get back this Nginx homepage. Now, we are also provided some rules on port 8080 and port 80. So let's check them as well. Again, I'm going to use the same format, SPC cluster local port 8080, and that works too. And okay, even this works as expected. So okay, so we have covered the concept of services as well.
So a couple questions have come through. One is, we've typically not done it before, but is it possible to be able to show rolling updates and rollbacks of deployments?
Yeah, that should.
And then I know you're talking about services, but there are a couple of questions. And then the other one was, who creates the DNS service for each namespace?
DNS service for each namespace.
I'm not really sure what.
So, like, okay.
Well, we'll take one question at a time. Why don't we first do the rolling updates and rollbacks?
So for doing the rolling update, basically, if I don't have that manifest over here, what you can do is, or you, should I just? Is it okay if I just use the Kubernetes docs to go over it?
Yeah, of course.
Yeah.
Oh, maybe you could, in the manifest, instead just change the version of the Nginx, like, and then you can just do the apply.
No, so I want the spec.strategy also in it.
Okay.
I can just go to, there is one thing that I was using.
So there's one, I think she's looking specifically, there is a spec that is out there where you can specify what kind of strategy you want for the rolling update or rollback, and so she just wants to look that up real quick.
Yeah, just a second.
Versus just changing so typically, while she's looking it up, I can describe it. So typically what you can do is you can just change the manifest itself. You can do a kubectl apply of that manifest, and then it will automatically update your deployment.
I'm so sorry, I just need so I already had that manifest in one of my GitHub repositories, but right now I'm not finding it in which one it is for some reason. Maybe I didn't push it. So for the rolling update, okay. Finally. Right. So for the rolling update, basically in this manifest, under spec, like we have provided replicas and templates, you need to provide another field called strategy. Now, in Kubernetes 1.8, you have two options for strategy as of now. One is rolling update and one is recreate. And yeah, you want to check out the rolling update option. So if you provide that rolling update strategy, along with that, you can also specify two more fields, such as max unavailable and max surge. Now, what max unavailable does is it lets you provide, like as the name suggests, it lets you provide the maximum number of pods that can be unavailable during that update. And max surge is the maximum number of pods that can be scheduled above the desired number of pods. So meaning in our example, replicas is 3. So if I were to specify rolling update strategy and max surge as say 1, we will have like 4 pods are allowed at the max to be scheduled during this update. So once I've specified this strategy field in my rolling update, and I just say do a kubectl edit or kubectl apply with a new image, my deployment by itself will undergo a rolling update. And once that is done, like you can check it using the kubectl rollout history command. I believe that's what it was. Um, rollout. Right. Checking the rolling. Yeah. So you can use the kubectl rollout history command and it will give you what all revisions took place. So, right. So for doing the rolling update, you don't have to do anything much. You just need to specify the strategy in the manifest and Kubernetes will take care of the orchestration logic of your update. I hope that answers the question. What, so I'm not sure about the DNS namespace. I'm not sure I get the question.
Yeah, I don't know if the question is quite clear. Okay,
Okay.
Why don't you continue and then I can try and answer through the chat.
Sure. Okay. Thanks. Okay, so we'll move on to the next resource, that is config map. So basically, a config map lets us create files within Kubernetes and then expose them to pods. Now, some applications need certain configuration files at runtime, but we don't want these configuration files to be baked into the container image because then every time this configuration changes, we'll have to change the image as well, like recreate the image, and we'll have to redeploy the pod as well. So config map lets us avoid all of that, and it lets us change values of these configuration files in the existing pods. One such example will be let's take a look at the Docker Hub Nginx. Okay. So over here, as you can see, while starting the Nginx container, you can you can provide the Nginx configuration file, and this will work perfectly fine for a container because we know where we are starting this container, like on which host we are starting this container, and so we are also sure that on this particular host we have the configuration file present on this path. But the reason it won't work for a pod is, first of all, we don't know where exactly in the cluster will our pod get scheduled on. Like if we have multiple hosts, we don't know which host this pod will get added to. And we also don't know whether that host has this configuration file on this exact location or not. And that's why we can create a config map beforehand and then provide it to the pods like that we want to access this config map data. Now, there are 2 ways to provide this config map data to a pod. Like we can provide it via environment variables, and we can also do volume mounts for that. So, okay, just going to. So this is what a config map manifest will look like. Kindly config map, and I'm naming it test CM. Now this data field in the config map is what actually provides the data that the config map will store. It's a map with key value pairs. So right now I'm just providing 2 keys, key 1 with value 1 and key 2 with value 2. And I'm going to create this config map. Okay, so it says that the config map has been created. And so I did the kubectl get command again, but I also provided the -o YAML flag. So what this does is it gives like the detailed description of the resource that you're trying to list or get, and you can see that the data field has the key value pairs that are provided via the manifest. Okay. Now let's see how you can pass this config file to a pod via environment variables. So for this, we are using this manifest to create a pod with the name env config map as pod, basically env cm pod. And within that, I'm just running one container with the image Ubuntu. So now this is how we'll provide the config map as environment variables. Under the field env, you will provide, like you'll specify what you want your environment variable to be named. So I want to add one environment variable with the name primary key, which will take its value from the config map, which we just created, that is testcm, and it takes its value from the key1, and we'll add another environment variable for the key2. We'll name the environment variable as secondary key, and yeah, it's taking its value from the testcm config. So let's go ahead and create this pod. So this pod has been, it's still in the creating stage, but it will get created and it's running now. So let's exec into this pod. So I'd added those two environment variables and hopefully they have been added correctly with the right values that we set. And they have. So if you can see over here, we have the key environment variable named primary key, which has the value 1, which was the value of the key1. And similarly, we have the secondary key with the value 2. So this is how you can provide config maps via environment variables to a pod. And now let's see how you can do the same using volume mount. So for that, we'll create another pod with the name volume cm pod. And sorry, I'm creating a single container within it with the image Ubuntu. So for the volume mounts, I'll add this volume under the volumes field. And I'm providing the testcm config map that we just created. And if you see under spec containers volume mounts, this is where you'll provide the paths like within the container at which this config map should be available. So in my case, the path is hcconfig. So let's go ahead and create this pod. And it's getting created. Okay. So now I'm going to exec into it to see how the volume, whether the volume mount is working as expected. So the mount path that I specified was hcconfig. So let's go to that. Okay. So it did create two files. One file is for the key1 and the other is for key2. And the contents of these files should be the values that were provided to these keys within our config map, which were value 1 and value 2 respectively. So yeah, the content of key 1 is value 1, if you can see over here, and the content of key 2 will be value 2. Okay, so right. So like a few restrictions of using config maps. You need to create the config map before you can reference them via pods. Like in both our pod manifests, we had, whether we were using environment variable or volume mount, we were providing the name of that config map testcm. So that needs to be created first. And config maps can only be referenced by pods within the same namespace. So that's one more thing. Okay. So now I'll go over a detailed example of what we just covered. And for that, I'm going to use the nginx configuration file. Like I'm going to provide this nginx configuration file as like via config map to one of my deployments. This is what the config file looks like. It's very simple. It just proxies to rancher.com. And I'm just going to run this command to create a config map. Now in this command, you can just you have like flags such as from file to provide the path of the file that you want to use to create a config map. And it says that the proxy CM config map has been created. So let's check that out. Okay, so now earlier when we had used the manifest to create the config file, we had provided the data field with the key value pairs. But over here, we just provided the file path, and it created the data field by itself. So the key that it uses is the file path, and the value is the entire content of that file. So our config map has been created. Now let's see how we can create a deployment which can use this config map. So again, oops, I think I forgot to change this to apps v1 beta 1. Let me just do that quickly. Okay. So again, right over here, this is where you'll provide the volume mounts, and the mount path that we are providing will be h3 nginx conf.d. This is just because this is the default path that nginx will use to look for any configuration file. And we'll also we'll add the volume with the config map proxy CM that we just created. Okay, so I'm going to create this deployment. Oh, before that, I just wanted to quickly show that I've also added the spec label app:/proxy. So this label again will get assigned to any pods that are managed by this deployment. Okay, so this proxy deployment has been created. And you can see that both the pods are in the running state. So now I'm also going to create a service for this. Right, and this service again has the spec selector field, and in that we'll provide app proxy. So again, what this means is any traffic that comes to the service will be routed to any pods that have this label app proxy on them. And one more, the traffic routing rule we provide is from port 80 to port 80. Sorry, there was a question.
Yep, someone asked, can you show the proxy deployment on the Rancher UI?
Rancher UI. So I don't.
I'm not quite sure.
Oh yeah. Oh, you mean through the dashboard or?
Maybe, I'm not really sure.
I can
maybe show the deployment. I think
pods.
Because we're creating a service where you can then connect to that pod. So maybe on the service. Did you create the service?
No, not yet.
Okay. Yes. The dashboard.
Oh, the dashboard. Okay. So
okay, he sees it.
Okay.
Okay.
Okay, cool. So I'll go back to the service. I'm going to create this. Okay, so this proxy service has been created, and now let's see if we had created a config map for our nginx configuration file, and then we created a deployment to which we are passing this config map via volume mount, and we created a service for that as well. So let's see if we can exec into a pod and do a curl request on this proxy service, and as a final result, it should give us the nginx homepage. No, sorry. Okay, let's just see. I'm going to exec into the pod again. Right. And the proxy service has been created. So now the nginx configuration file was actually proxying to rancher.com, and so that's what we should get. We should get the Rancher homepage if we do a curl on this service. So proxy.default.svc.cluster. Okay, and that's what it does. It gives us the Rancher homepage. And another rule that we had provided was port 80. So even that works as expected. So that's it. So we cover the concept of proxy as well, and I'll move on to the next concept.
There's a couple of questions coming in. One was, how can you expose the Kubernetes API or Nginx to be reachable in the network? Because we want to use manage IQ or Kubernetes GUI, but both ask for IP and port. Only we can't specify the link, the HTTPS link that we get in the kube config, I assume. And at this moment, the example is all in the cluster, no exposing externally. So maybe it's like, how can you? I'm not sure exactly what the statement is saying, but maybe I would interpret it as, how can you access like Nginx externally?
So if you expose it, like maybe we'll go over the ingress resource.
Yeah, I think the ingress might be something that will help you there. I'll come back to that question. Another one is, let me read it real quick internally first. Okay, this one would hopefully be. Okay, if there are multiple containers in a pod, I know we can connect to a specific container by using kube control exec with a container name. How can we list the containers within a pod using the kube control command?
I'm not sure, but I think if you do the kubectl get command with the -o flag, which gives you the detailed description, or even the kubectl describe command, that will definitely list the different containers running within the pod.
So I think, so it's get pod or get -o pod, right? That will give the
details. Get the pod name and -o, whatever format you want. For example, YAML, -o YAML. Yeah.
Yep.
And or kubectl describe.
Or kubectl.
Okay. That should do it.
Okay. Let's see. I think Mario's trying to figure out how can we access the Kubernetes API externally. I don't know if you can access it externally.
I'm not sure.
I actually don't think because Rancher is managing the Kubernetes API, I don't believe you can manage it directly outside of Rancher. I think that's what you're trying to do, Mario. If that's not what you're trying to do, write another question to me and I'll continue to try and answer it.
I mean, over here, if you generate the kubeconfig, and then you can go to this.
Okay.
So this gives you all the API endpoints, and you can go to any specific one. Say if I go to APIs apps v1 beta 1, it should give me all the deployments that have been created till then, and the deployment falls under the apps v1 beta 1 and whatever other resources fall under it. So maybe this is how you can use the Kubernetes.
I think Mario's trying to maybe try and use some other service to be able to manage the Kubernetes setup that we've created here. That's what it seems like from here. And I don't, from my understanding, I think that's possible. I think right now it's just meant, the Kubernetes setup that we spin up is meant to be managed by Rancher. There's a lot of, benefits with using Rancher in terms of using our UI. So if you're trying to use some other application to manage the Kubernetes setup that we've launched here, that won't work. But what you might want to try and do is look into, so it sounds like you're trying to find something that is going to launch Kubernetes for you and you want to use a different third-party application to manage it. You could also look into, we just recently did I don't know if it's beta or what state it's at, but there's something called RKE engine where basically you can launch Kubernetes on your host itself, and then you can probably manage it what you're trying to do, Mario. I'm going to send you the link to that blog post, and maybe that will get you started of what you're looking for. Okay.
Okay.
Why don't you continue?
Okay, so I'm going to cover this last resource, that is an ingress. So we saw that the proxy service or the Nginx service, all of them got a cluster IP address, and using that, other pods were able to access it. But now, if you want to make this available to the outside world, we'll use something called like an ingress resource. So ingress defines a set of routes to route inbound traffic to a cluster service. So it basically exposes the cluster services to outside world, and we can define various routing routes based on host and port.
I'm just going to interrupt. I know we're running past the hour that is allocated for training, so obviously if you have somewhere to go, we do record these trainings. They go up on our YouTube site. So if you have to leave and you want to catch the end of what we talked about today, or you want to rewatch anything, these are all recorded. Okay.
Yeah. Right. Yeah. So going back to the ingress resource, this is the manifest for it, and if you can see, there are like three dashes, like lines over here. What this means is, using that, you can provide multiple resources within the same manifest, and that's what I've done here. So these are two different ingress resources, and one is named proxy, and the spec.backend is where like it's a service port combination. So the ingress traffic is routed to the endpoints that match this combination. So now we are creating this ingress named proxy, and also an ingress resource named Nginx with spec.backend Nginx. And okay, so proxy is using port 9000 and Nginx is using port 9002. So let's go ahead and create them. Okay, so they are getting created right now, and we just have to wait a few seconds to get the address for them. So like Denise had explained earlier, like Rancher would create default Rancher load balancers when we have created an ingress resource. And okay, so they have been assigned the addresses. Now, this address basically belongs to one of the nodes that have been added to our Kubernetes cluster. So for Nginx, the address is this, and I think we had used port 9002 for Nginx. Okay, so let me go to this address on port 9002. Okay, so it works. So we get the Nginx homepage over here. And let's see for the proxy service if we get the Rancher homepage on this address on port 9000. Great, even that works as expected. So we have covered the ingress resource as well. And yeah, I think those are all the resources that we wanted to discuss for this training session.
Yep. Okay, so I think if anyone else has any other questions, obviously this is meant to be an intro to Kubernetes training itself. As I mentioned earlier, another great place if you have additional questions that we weren't able to answer, or you are later trying it out yourself and you have more questions, please join us on Slack. It's slack.rancher.io. We have a Kubernetes channel. The community there is very active. They're very responsive. It's not only Rancher employees. We have a couple of our employees who are on there helping people, but mostly it is the community helping out each other, people who have been using Rancher to do probably maybe what you're trying to do. If you have specific questions, they can help you. So I really encourage you to go look there. Otherwise, I think that's the conclusion of our training today. I don't really see any more new questions coming in. Hopefully you are all able to get something out of it, and we do run these usually monthly as well. The schedule is still being determined for 2018, but the plan is to continue these monthly. So hopefully if you have any questions, join us again. You can ask us come back, ask whoever's doing the training then some questions. Otherwise, thank you, everyone. Have a great day.